When I tell people that we use n-1 in the denominator for estimating population standard deviation, many people want to know why. This video will explain the mathematics behind why we use n-1 and what we mean by degrees of freedom. The degrees of freedom refer to how many options exist for variation in our data. Specifically, it means degrees of freedom to vary. Let me illustrate using an example of making choices when choosing positions for a softball team. Degrees of freedom will refer to the number of people who get to make a choice. There are 9 positions on the softball team: pitcher, catcher, shortstop, first base, etc. And there are 9 of us. We draw straws to see who gets to go first. The first person picks a position to play on the team. The second person chooses from among the remaining 8 positions. The third person chooses from among the 7 remaining positions, and so on. Each person gets to choose a position. But who does not get a choice? When we get to the 8th person, that person chooses between 2 remaining positions. But the last person is stuck with whatever position remains, so that person doesn't actually get to make a choice. When choosing among 9 positions, only 8 people get to actually choose. The last person's choice is chosen for him, based upon the choices of others. You have n-1 choices, or degrees of freedom to choose. Now let's apply this to a sample. We have chosen a sample of 9 subjects from an unknown population. The mean of our sample equals 5. What do you estimate will be the mean of the population? Because the sample mean is the best estimate of the population mean, we estimate that the mean of the population will be 5. So what is the formula for the mean? The mean is the sum of x divided by n, which we estimate must equal 5. So we are now going to select 9 new scores from this population with an estimated mean of 5. The sum of x divided by 9 equals 5. So what is the sum of x? It has to be 45, because 45 is the only number that can be divided by 9, our sample size, to equal the mean of 5. The values in the population can vary, but they must still average to the mean. We have chosen our 9 people, and we know that their scores have to add up to 45 so that we get that mean of 5. Well, let's see what their scores were. If you like, get out your calculator and enter a value of 45. As we see the numbers from our sample, subtract them from 45. The first person got a 5. That leaves us with 40. The second person got a 6. That leaves us with 34. The third person got a 4. That leaves us with 30. Next is 5. That leaves us with 25. Next is 4. Leaves us with 21. Ooh, the next one's a 7. That brings us down to 14. Next is 3. That leaves us with 11. And the next to last person got a 5. We only have one more person left. What does his score have to be? The last one has to be a 6. You can vary any or all of the population values, n, but the last value, n-1, will always be defined for you. You have n-1 degrees of freedom to vary. Population estimates using n tend to underestimate the true population values. So n-1 is a corrective factor.